Hello children, welcome back to our next session of practical chemistry. Now we are doing the identification of acidic gases, and we have done carbon dioxide, sulfur dioxide. We've also done chlorine and hydrogen chloride gas, right? Now the next gas in this acidic gas which you're going to do today is nitrogen dioxide gas. Now there are something like this is an acidic gas, right? Any gas which when dissolution with water form acids is an acidic gas, and it gives the litmus test, right? And acidic gases turn moist blue litmus to red. So I'll be arranging for red and blue litmus paper, and it should be moist, one thing. And for preparation of nitrogen dioxide, it would be action of heat on lead nitrate, right? So I've taken lead nitrate here. Now lead nitrate, it would be action of heat on lead nitrate, and the litmus papers are arranged here. Red and blue litmus paper. So you'll just moist it and keep it here. This is moist blue and moist red litmus paper. So I'll arrange it and keep it here. Now one very peculiar characteristic identification, not peculiar, not even characteristic, one important identification of nitrogen dioxide gas is its color. Now it is the color. When it is evolved, then I'll show it to you what is the color of that, and then you will remember that. And it's conformatory test. Now these things, for conformatory test we need potassium iodide solution. So this is potassium iodide solution which is out here. So when I dip filter paper in potassium iodide solution, we get potassium iodide paper. So this is what we need for the experiment. So let's start. So first of all, I have to start with the I'll need a matchbox, right? So we'll light it. Now you can see it also. Okay, and what we need, this is lead nitrate, and I need a test tube holder. Now lead nitrate, when we heat, you will hear its peculiar sound also. Now see. Can you hear? Can you hear this sound? Peculiar crackling sound, right? Okay. So it is decomposing. So lead nitrate is decomposing. I'll put moist red and blue litmus paper near the mouth of the test tube. Now see, still now the gas is not evolved because the gas is having, as I said, a different color. Can you hear this crackling sound? This is known as decrepitating sound in chemistry. Decrepitating sound. Now the color, reddish brown color is NO2. NO2, now you can clearly see the color of the gas. Reddish brown. So what is color of NO2? Reddish brown. So now we know that the gas is evolved. Now you see what has happened. What has happened, children? See? Can you see the color change? Can you see the red blue litmus changing to red? You have seen it? Right? Now what is the next test for that? The combustibility test. Now, see, okay, I'll stop heating it. We'll do the potassium iodide test. So I've dipped it in potassium iodide and bring it here near it. Now potassium iodide solution turns brown. Now this NO2, I did not arrange it. Let me dip it in this. This is potassium iodide. It was already with NO2. Okay, I'll dip it from the other side and then show it to you again. This is potassium iodide solution, and I'll dip the filter paper strip in that. Okay, so this is potassium iodide solution. Now let me bring it near NO2. The test of NO2 is it turns potassium iodide paper brown. Now it is NO2 is being evolved. Let me heat it once again. But whatever NO2 is there, it is turning it brown. Can you see it? Or a little bit more heating? More heating, let more NO2 be formed. Now I am not showing combustibility test in this, reason being is, see NO2, it is turning potassium iodide paper brown. So this is the test for NO2. Conformity test for NO2 is it turns potassium iodide paper brown, right? Now, reason I am not showing combustibility test because when lead nitrate is heated, we have done this in thermal decomposition of compounds. It gives two gases. One is NO2 and another is oxygen. Now, oxygen is supporter of combustion and NO2 is non-supporter of combustion. But still, oxygen is there, so it would not show a very good test for non-supporter of combustion. So that is why we'll just write the property that NO2 is a non-supporter of combustion, non-combustible and non-supporter. So in any experiment when only NO2 is there formed, then you can easily show non-supporter of combustion. But we have NO2 by action of heat on lead nitrate, right? So it's conformatory test and its color reddish brown. So all this you have to remember. So let's see how to write it. Now the aim is already on the board. We'll write in the same format as we have done in the earlier experiments. So experiment number 8. This is experiment number 8. Write number over here. Number 8. Okay. And then aim. What is aim? Aim is identification of NO2 gas. Aim is identification of NO2 gas. So this is aim only, children. So aim, you will write identification of NO2 gas. I am not copying it again. Then you know what you have to do. You have to write experiment, observation and inference, like I have told in all my previous videos. So you can do that way. It is, you can write the headings. Write in block capital experiment, observation and inference. That you write full form. Now what is the first thing? We are preparing NO2 gas. So take small amount of, small quantity, small amount of what we took, children? Lead nitrate, PbNO3 whole twice in a test tube and heat gently. This is the first step, and heat gently, right? There are a lot of observations, so I am writing first. Lead nitrate decomposes, PbNO3 whole twice decomposes with some sound, no? With what? I have told you, I will be telling you the word decrepitating. D-E-C-R-I, decrepitating sound. Decrepitating sound. This is your first observation. Action of heat on lead nitrate is in detail in practical chemistry, right? So we are doing it here. So that time we need not repeat it. So lead nitrate decomposes with decrepitating sound. And the main observation, reddish brown gas evolved. Reddish brown gas evolved. Well, you know what your inference would be. Gas may be NO2 because reddish brown. So very few gases are reddish brown. So reddish brown gas it is. So it is gas may be NO2. But till we have done the chemical conformity test, we will never write on the basis of color that it is gases NO2. Color is not the conformatory test until it is only for NO2. Had it been only gas with reddish brown color, then it is conformatory, but otherwise not, right? Then second would be, you know what you have to write? Litmus test, you know we have done in all the acidic gases, same thing you will be writing. Second, litmus test. Remember what you have to write in the second case? Litmus test. Third, combustibility test. Combustibility test. You remember the statement which I have given in carbon dioxide gas. I have given the statement in all the gases combustibility test. Introduce burning splinter into the test tube. Combustibility test statement is introduce burning splinter into the test tube. Test tube gets extinguished. What will you write here? Test tube is, I'm so sorry, not test tube. Burning splinter is extinguished. Burning splinter is extinguished. And what is the inference? Gas is non-combustible and non-supporter of combustion. We have written in the previous experiment all those gases which are non-supporter and non-combustible gases, non-supporter of combustion, we have the same test, right? So you wrote it in CO2 also, you wrote the same thing in chlorine also, you wrote the same thing in H2S also. In fact, you wrote the same thing in SO2 also. Till now, all the acidic gases, you wrote the same thing. So these are same, so I am not writing it. Now directly what? Conformatory test for NO2. And what is the conformity test for NO2? That would be number 4. Bring potassium iodide paper near the gas. Bring potassium iodide, Ki paper near the gas. I showed you. So what? The colorless, it was colorless. The colorless potassium iodide paper, or you just write potassium iodide paper turns brown. Don't write colorless. Potassium iodide paper turns brown. The potassium iodide paper turns brown. That's your confirmatory test, children. It is the confirmatory test. And now you can write down gas is confirmed to be NO2. Gas is confirmed to be NO2. Now on the plain side there are reactions. I'll give you reaction number 1 for lead nitrate. Lead nitrate on heating gives lead oxide plus NO2. This is one gas, and another gas formed is oxygen. There are two gases formed. Just balance it quickly, children. It would be 2, it is 2, and it is 4. Now check whether it is balanced or not, right? And what is the conformity test? So what is the conformity test for, I've just now told you? It is for, with what? Potassium iodide. So potassium NO2, this is number 4. NO2 plus potassium iodide, Ki, gives what? KNO2, potassium nitride plus iodine, free iodine. So when it is formed free iodine, you can just quickly balance it. Now it is oxygen 2, nitrogen 1, potassium 1, iodine 2. So we have to put 2 here. When you put 2 here, it goes 2 here. Now let's see 2, 4, 2. Is it balanced? It is balanced chemical equation. So this is what you have to write for your NO2 experiment. This is second is litmus test, which you have written in all the experiments. This is third is combustibility test, right? And what is the main thing what you have to remember? But NO2 gas is reddish brown in color. This is a very, very important observation. NO2 reddish brown in color. It is acidic gas. It is non-supporter of combustion. And what is the conformity test of that? It turns potassium iodide paper brown. Now paper we can't say colorless because actually the paper is white in color, right? So solution is colorless. So paper is white in color. See, if I take a simple filter paper which is not dipped in anything, it is white in color. So when I write colorless potassium iodide paper, it is the wrong statement. So it is potassium iodide solution is colorless. So either we write potassium iodide, colorless potassium iodide solution turns brown, that's correct. Or we write potassium iodide paper turns brown. Don't write colorless in that case. When we talk about solution, you can write colorless. See, this is colorless. Water is colorless. Water is not white. Milk is white. So water, we don't say white, it is colorless. So potassium iodide solution is what? Colorless. Right? These things you have to remember when you're writing the experiment. Alright children? So this is NO2 experiment. The H2S gas which I have not done till now is the reason being I don't have a certain chemical which is needed to show that test. So that is why I have taken NO2 gas today. And in any of my videos I'll be showing H2S hydrogen sulfide gas also. So these all these gases including H2S, these are the acidic gases which are in your syllabus. So you'll be writing this experiment. Children, please do write all their experiments properly. You have to maintain the lab manual and don't let my efforts be wasted. When arranging chemicals and doing it is not an easy thing, but still if it is done, it is your duty that you should at least see the videos carefully. See it again children. By seeing it only you can remember all the observations and conformity test. Very, very important. You have to remember all the observations and conformity test. You will get the theoretical questions based on that. That is, you have to write in your exam. Right? Not just perform practical, you have to write. You can be asked, write conformity test for NO2 gas. You can be asked, name a gas which is reddish brown in color. Like that. Right? Name a gas which is greenish yellow in color. So you have done chlorine gas. So there are observations there. Or what do you observe when lead nitrate is heated? You observe reddish brown gas evolved, right? All these things. So this is what you have to learn. So that's why all the experiments to be written, reactions on the plain side and complete your work. Alright? Take care. God bless you. Bye children.